Hello, my name is Sojinder Singh. My student ID is 20336899 and my today's presentation is Personal Expense Tracker and Introduction. The Personal Expense Tracker is a mobile application designed to help a user manage their daily financial activities. It enables individuals to record, organize, and review their spending in a simple, user friendly manner. By providing clear insights and analytics, it supports better financial planning and informed decision making. Use case diagram. The use case diagram illustrates the primary instructions between the user and the personal expense tracker. The highlights core functionalities such as account management, expense recording, viewing history, and insights. Relationship between use cases like extension and inclusion show how additional actions enhance the main functionalities. Use case documentation. Use case name, record and manage expense. Actors use primary. Goal allows user to record daily expenses, view historical data, and gain insights into spending patterns. Use case documentations. Preconditions. The user account exists is authenticated, the application is installed and operational. Post conditions. Expense data is stored securely in the database. Expense lists and analytics are updated immediately. Main flow. The user logs into the application. The user select and expense from the main menu. Users input expense details. The system validates the inputs. Expense is stored in the SQLite database. User navigates to view expenses or insights and charts to receive. Use case documentations. Alternate flow. Invalid input trigger an error message prompted corrections. If no expense exists, the list and chart display or no data message expressions. Database connection failure is reported to the user with retry options. Applications crash preventions mechanisms handle unexpected input and the operational gracefully. Special requirements. Secure password storage using SHA-256 hashing, support for light and dark modes. Fast performance with large data sets using background threading. Class diagram. Show key system classes, attributes, and the method. Demonstrate relationship between activities, database models, and the utilities. Highlights responsibility patterns, singleton, database helpers, and the password encrypted via decorator patterns. Discussion on the uses of the design patterns. Design pattern ensure module testable and the maintainable code. The applications implements the repository for data access, abstractions, singleton for the SQLite helpers, the decorator for secure password processing, and an adapter for recycler view lists, factory for chart type creation, and the observer for reactive UI updates. The recommended extension to standardize analytics and the improve responsiveness. Sequence diagram shows interaction between user and system components for login, expense recording, history viewing, and the chart generation. Demonstrates flow of request through activity responsive in the database. Highlights method calls, data retrieval, and the response handling for efficient user operations. User interface diagram. Display six primary UI screens: login, register, home, and expense list, and the charts. Ensure simple, intuitive navigation for a smooth user experience. Each screen focuses on the essential feature, reducing culture and clutter and the improving usability. Test plane. Define scope, functional, non-functional, and the regressions test through login, expense, CRUD, filters, charts, theme, and the persistence. Use until integration, the UI, UX, database, performance, security, and the comparability testing, and the Android API 2.4.2.3.5. Success criteria: zero critical defects, 95% core pass rate, consistent data integrity. Conclusion and the critical evaluation: the application successfully meets the core goals of expense tracking, visualization, and the user friendly interaction. User or use of design pattern ensure maintainability, scalability, and the secure data handling. Further improvement is possible through advanced analytic load sync and the automated testing for the enhanced reliability. References. Dathan B and the Ramanath S2520 interactive system and the model view controlled architecture in object-oriented analysis design and the implementation and the integrated approach PP345407 Cam Springer Nature Switzerland Saharuddin MH Sad AF Yani and Manaf A2520 development of student expense tracking system using optical character recognition International Journal of Artificial Intelligence 12 PP1 to 10 Singh G and the Yoshike 2025 expense tracker web application in the progressive computational intelligence information technology and networking PP 570576 CRC Press. Thank you.